Sorry, CK Trill. What do I want for Christmas? Right now, just a break. That's it. Just a pause. Which Caleb is that? I can't, like... My guess is Caleb Key because he's got a Naruto background. Yeah, that's what I thought. Hi, Ethan. Okay, so before I kind of start this stuff, and while I'm waiting for people to come on and start, um, list of topics are... I guess I should switch pens. Oh, no. List of topics at the top of the screen. That's going to show up here right now. Just kind of look at those, make sure you're familiar with those are. Try to think of what those mean. If you don't totally know what one of them means, that's fine. I want to go over all of this stuff as well as I can. Obviously, it's not going to be good as like going over it the entire semester like we have been. But right, we can get at least somewhat close. So while people are waiting to, this stuff in white, that's going to be the senior stuff, okay, which is also covered with juniors. But as soon as I finish that, that part one and part two of the practice test, the senior stuff is over, and then the logarithms are all that's left. And we covered logarithms with juniors. So juniors who are kind of waiting for that, you don't have to watch the first part. That's fine. This will probably be a little bit longer than normal, which is okay. But if you have questions over any of the first part, you're welcome to stay for that too. All right. So we're closing in on 35. So again, if you don't have that practice test, it might be a good idea to have in front of you if you're able to. So if you're able to print it or something real quick, it's not a bad idea. Or if you have a question on your notes, that's fine too. But don't just be like watching me do this. Try and actively go through this. The more you're able to do that, the more this is gonna help you. Okay. Also, I don't want this to just be like the only thing you're doing to study. If there's, pieces of this test that you absolutely 100% know, stop and go over something else. Okay, you don't need to watch this entire thing if you understand half of it. If there's a question that you don't understand, stay for that, and then I'll try and go over that as best as I can. Okay, so we'll go ahead and start, and like normal, I'm going to kind of go through this as best I can, and then as you have questions, just let me know, and I'll try and keep a close eye on what's happening. Okay. So again, just like in class, this is in two parts. First part has to do with lines, equations of circles, a little bit of factoring, a little bit of quadratic formula, a little bit of graphing, asymptotes, rationalizing, and then the systems of equation stuff. And then that last question is just the transformation stuff. My guess is people have question over this, so I'm obviously going to save that for last. And then once we get past this, juniors, we'll go over log stuff. Okay. So let's just start from step one. These first couple of questions shouldn't take too long because they're just lines. Okay. Sketch the graph of each line. We should know by now y equals mx plus b. I will do 11, but let me get there. Okay, so we'll kind of go through this early stuff pretty quick. So from y equals mx plus b, m, that's our slope, b, that is our y-intercept. So we just identify those, right? So our slope is -3/2, that's m. Our y-intercept is 2. Okay, so we plot the point at 2. We go down 3, right? -3 over 2. That's our rise over our run. So we go down 3, so 1, 2, 3, and then right 2. Down 3, right 2. And then we just draw a line connecting that. This won't be too straight. Okay, and that's our equation of line. That's all I'm expecting. There's really no work to be done there. Just identify the slope, identify the y-intercept. As long as you're able to tell me that stuff, you should be fine. Okay. Number 2, write the slope-intercept form of the equation of each line. You're only getting one of these. So just like above, identify the y-intercept. Right, that y-intercept b is -3. And then we get a slope. Okay, and it looks like for every one we go down, we go right one as well. Right, so each of these lattice points, right, we're just going down one, right one, down one, right one. So m is just -1. Right, so our equation of the line, y equals -1x minus 3. Easy stuff. Okay. And then a little bit harder of the linear equation. If you're able to get this, you understand lines pretty well. Given 2 points, right, I'm going to label these x1, y1, and x2, y2. Given these 2 points, we need to find an equation of a line. So the first thing we do with this is we find the slope, which is the difference in y's over the difference in x's. Right. The rise, that's the difference in y's. The run, that's the difference in x. Right. X is horizontal. Y is up and down. Okay, so the difference in those things should give you rise and overrun. Okay, so if we plug y2 minus y1 in, we get 5 minus -1. And x2 minus x1, that's -4 minus -5. A lot of people have been missing negatives, especially in the last test, which is reasonable. There's a lot of stuff going on in the matrix stuff. But we got to be really careful, right? We're always subtracting here, no matter if those things are negative. Okay, so it should look like what I have written. So 5 minus -1, that's really 5 plus 1, which is 6. -4 minus -5 is really -4 plus 5, which is just +1. So that's equal to 6. That's the first part. That's our m. That's our slope. And what I would suggest, and we went over this earlier on in the year, but is to finish this using point slope form. And point slope form is y minus y1 is equal to m times x minus x1. You don't have to do that, but this is the easiest way to do it, because I don't care if this is simplified or not. Okay, when you try and solve for b and y equals mx plus b, things can get a little hairy. But like again, I would just stick with point slope form. Okay, so if we just plug that stuff in, y minus y1 equals m times x minus x1, we have a y1 and we have an x1. So we have an m, so we just plug all that stuff in. Can I upload the video so I can go back? Yeah, I'm gonna plan on doing this. If your test is tomorrow, so if you're a junior, I would just suggest keeping this open. If you're not, it'll be uploaded by then. Okay, so back to this. If we just plug in y and 1 and x1, we get y minus -1 is equal to 6. That's our m, times x minus -5. And yeah, honestly, you can leave it like that. If you're uncomfortable combining that stuff, that's fine. This is what I'm looking for. Okay. Is there going to be a question like this asking for slope-intercept form? No, I don't care if you use slope-intercept or point slope. You can even use standard if you're really comfortable with it, but no one really uses standard slope-intercept or point slope. Most people, especially early on, they just use slope-intercept form. I don't care. As long as you're able to get an equation of a line, that's what I care about. Okay. And I can go over this later if you want to see it in points in slope-intercept form, but I want to move on a little bit just to get these easier questions out of the way. Okay. Number 4. Make sure to read these questions carefully. I know you have, but just so you understand exactly what I'm asking. Use the information provided to write the standard form equation of each circle. Okay, so the standard form equation of a circle is, oh, that doesn't look good. R squared is equal to x minus h squared plus y minus k squared, where r is your radius and hk is your center. And before we actually do this, remember that we're subtracting whatever h is and we're subtracting whatever k is. So even if they're negative, you're still subtracting those things. Okay, so in this case, radius is 2, right? So we have 2 squared is equal to x minus h, which in this case is 13, squared. Don't forget the squared, that's important, plus y minus 9 squared. And you can leave it like that. If you want to simplify this 2 squared, go for it. Either one of these, both of these are fine. Okay, both of those answer my question. Okay, so 1 through 4 should be like the first 3 that has to do with lines. You've been doing that since freshman year or before. So we should be good on that. Number 4, there's just this equation. We went over why this equation works in class. If you don't understand that, that's totally fine. I know it's been a while, but this equation we need to know because this is important for later on stuff. Okay. And then we move into factoring. We move into a lot of graphing, quadratic, and polynomial stuff. All right. So number 5 and 6, they ask you to solve by factoring. Okay. Both of those are important. Okay. So the first thing we got to do for 5 and 6 is just to factor the left-hand side. By left-hand side, I mean the left of the equal sign. Okay. So if we factor x squared plus 7x, there's 2 ways to look at this, and I explained this to a couple people in class. You could either look at this as what's in common between x squared and 7x, in which case x is in common, right? So if you pull out that x, that common x, we're left with x plus 7. And we know that that's equal to 0. If you have a product of 2 things that's equal to 0, one of those 2 things has to equal 0. So either x equals 0 or x plus 7 equals 0. So x is equal to -7. That's how I do it. If you're uncomfortable with that, just because it looks different, think of x squared plus 7x as x squared plus 7x plus 0 equals 0. And then you're answering the same question that we've been asking ourselves for this entire factoring thing, okay? Which is, what are factors of 0 that add up to 7? Okay, if that's the case, factors of 0 that add up to 7, the only one is 0 and 7. So we have x plus 0 times x plus 7 is equal to 0, and then you do the same thing. So either x plus 0 equals 0 or x plus 7 equals 0. This is just another way to look at it. It's the same thing. It's just if that makes you feel uncomfortable because there's no constant term, you can do that. Okay. If green makes you feel uncomfortable, great, do blue. If blue makes you feel uncomfortable, great, do green. Okay, so there's going to be one like this, one easier type quadratic question. Okay, is it going to only have 2 terms? Maybe. It might have 3 terms, but it'll be something where the leading coefficient is 1. Then you're going to have something where the leading coefficient, right, the thing in front of the thing squared, so in this case 2, it's not 1. So there's going to be some other number in front of k squared. What I do is I make the box, and we're just trying to find different areas of these boxes, right? So what always goes top left is 2k squared. What always goes down bottom right is that constant term, which in this case is -7. And then we just ask ourselves factors of each of these squares. Okay, factors of 2k squared, right? The length and the width, in other words. So the length could be 2k and the width could be k, right? Because 2k times k squared, if those are lengths and widths, it gives an area of 2k squared. Then we need factors of -7. Okay, and this is a little bit guess and check. Okay, so you have to be patient if you don't get it the first time. Factors of -7. Okay, we could try -7 and +1 or -1 +7. So let's say we try -7 +1. Well, then we get -7k and +2k. However, we need these two things to add up to -13k, right? So 2k plus -7k, that doesn't add up. Okay, so we have to retry where our factors are. So if that's the case, I'm going to try -7 down bottom and then +1 up top. Okay, so 2k times -7, that's -14k. K times 1, that's +k. -14k plus k is equal to -13k, so we know it works. So our factors are 2k plus 1 times k minus 7 is equal to 0. And then we do the same thing as before, right? So 2k plus 1 equals 0, or k minus 7 is equal to 0. And then we just solve as normal, right? So k is equal to -1/2, and this should be k, is equal to 7. And those would be our two answers. Okay, just like the polynomial test, I'm grading you on 2 things. I'm grading on you being able to factor, and I'm grading you on being able to actually solve. Okay, so for example, if this is a 4-point problem, which I think it was in the polynomial test, this part right here, that's 2 points, and then each one of these are 1 point. Okay, so that's the factoring problem. Solve each equation with the quadratic formula. Okay, so I'm going to write the quadratic formula on the right. Which you should memorize. Okay, I told you that a while ago, but if you didn't, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we just plug in a, b, and c. Okay, so in this case, a is 3, b is 3, and c is -90. So we just plug those in. Okay, so -b, that's -3, plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. Okay, when we simplify this, right, 3 squared minus 4 times, that should be a -90, right, because c is negative. When we simplify this, we end up getting negative 3 plus or minus the square root of 1089 all over 2 times 3, which is 6. Okay, now, I would like you to simplify this, all right? And if you have a calculator, you can just check square root of 1089 and then go from there. If it's a decimal, then you have a little bit of work to do. But if you plug square root of 1089 into your calculator, you get 33. So you have negative 3 plus or minus 33 all over 6. This can be your answer, okay? If I would rather you just get here than simplify and make a stupid mistake and be wrong. Okay, so what I would do is just stay here. That's fine. And then you do the same thing for the other one. Okay, so negative b, so negative 6 plus or minus the square root of negative 6 squared minus 4 times 6 times 5 all over 2 times 6. Then you simplify. This is one I have not actually done yet. So we get positive 6 plus or minus the square root. And I have a little bit of math to do. So 36 4 times 5 is 20 times 6 is 120. Yeah. 36 minus 120 is negative 84. Right, so all this is over 2 times 6, which is 12. I'm going to move this over here. So then we have 6 plus or minus the square root of negative 84 all over 12. Okay, and this is where I'm expecting you to be able to deal with imaginaries. Okay, I'm not going to give you like an explicit imaginary number besides one other. This is where it's going to show up. So we need to be able to simplify this fraction, but really this square root of negative 84. Okay, so if we take the square root of negative 84, we can rewrite this as the square root of negative 1, square root of 4, square root of 21. Right, 4 times 21 is 84, times negative 1 is negative 84. Okay, so what we're trying to do is we're trying to pull out perfect square factors of 84. 4 is a perfect square factor because when you square root it, you get an even, nice number. So when we simplify this, square root of negative 1, that's I, that's our imaginary unit. Square root of 4, that's 2. And square root of 21 stays as is because there's no other simpler terms to do it. Okay, so this 6 plus or minus square root of negative 84 over 12, this becomes 6 plus or minus all that. So 2i rad 21 all over 12. And again, you can leave it like this. Okay, but I am expecting you to be able to deal with those imaginary numbers. Okay, so again, if both of these are 4-point problems, some of the points are going to come from just knowing the formula. Some are going to come from simplifying. And then some are going to come from dealing with the square root. Okay, so in number 7, right, how I have it listed right here, that's how I would grade it. Okay, in number 8, there's a little bit more work to do, right? So 1 is just knowing it. 2 is simplifying. Sorry, that should be another 1 point. Right, and then half of the credit is dealing with the imaginary. Again, just like I graded the other test. Okay, so that's the factoring part. Factoring is going to show up next, but in a little bit different of a way. All right, so number 9, again, read the questions like carefully. So graph the following by using the leading coefficient test, finding the zeros, and using the intermediate value theorem. So I'm going to do this so it's all colored. We'll do this in red, and then we can do the testing in blue. All right, so the first thing we got to do is just identify, we got to do the leading coefficient test. Why do you simplify the second one but not the first? I'm guessing you mean between number 7 and number 8. So in number 7, we're really not simple. We are simplifying. Okay, we're simplifying this square root. I'll highlight it. We simplified the square root, but we're not simplifying the entire thing. Okay, and we're doing the same thing on number 8. Okay, we simplify it, and it's gonna be hard because I don't have anything that works with black highlighting. Okay, so we get here, right? We have to simplify the square root of negative 84. Being able to do that is worth half the credit on that problem. So we are simplifying it. We're not simplifying it totally because we're leaving this as is. I hope that makes sense. We're getting to the same point in both questions. We're getting to negative something or something plus or minus something over some number. In number 8, though, I'm asking you to be able to deal with the imaginary number. Okay, I can go back to that. I want to get through some of these, and then we could spend a little bit of time on asymptotes and go from there. All right. Mr. Bam, can you move your face cam to the top left corner? Oh, my bad. I'll scroll down for a second. I forgot about that. I'll actually just make it smaller. There we go. All right, so people can see it now, and this is a good time to kind of catch your breath. On number 7 and number 8, we're getting to the same point in the question. In number 8, though, I'm asking you to be able to deal with the imaginary, right? So that's the square root of some negative number. Something like this, right? So the square root of negative 84. That's when I'm really asking you to be able to simplify. And then our answer is going to look like this. Okay. So number 9, graph the following by using the leading coefficient test, finding the zeros, and using the intermediate value theorem. Okay. First thing we have to do using the leading coefficient test. Okay, and the leading coefficient test says that we should state our degree and our leading coefficient, and that gives us a general shape of the graph. Okay, so I'm going to have a graph drawn right there. Okay, so the first thing we do, we get the degree. The degree is the highest exponent in the polynomial. And that's 3. Okay, the leading coefficient is the thing attached to that x cubed, which is 1 in this case. Okay, 3 is odd, and that tells us this is going to look like some kind of s. And 1, the leading coefficient, is positive, which tells us it's going to start from the bottom and end up top. Okay, so our graph is going to look something like that. We don't really know what's happening in the middle yet, but that's what we're going to do next. That's what those two things tell you. Okay, if it was even, it'd be going up in both directions, unless it was negative. Okay, right, so just as so people see it, there's even, positive, right, so the degree and the leading coefficient, right, that would look kind of like a parabola, right? So it'd be going up both directions. There's even, negative. That's the same thing except it's upside down. Then there's odd, positive, which looks like the S. And then there's odd, negative, which is just flipped upside down. Okay, so those are like the 4 cases that you could run into on this. So that's what you do first. I think that's worth 2 points, if I remember right, on our old rubric. Just identifying the degree, the leading coefficient, and then telling me what kind of general shape you're going to get from that. Okay. Right. So next we need to find the zeros. Finding the zeros is where it can get, it's probably the hardest part of this problem. And really that, if you know how to factor these things, it's not very difficult. Okay, so finding the zeros, we are dealing with our equation and we're setting it equal to 0. And we're factoring as best we can. There are 2 different types of things that could show up. One is the one that's shown, which is factoring by grouping. Okay, so if you have 4 terms, you're going to be factoring by grouping, at least in our cases that we're dealing with. The other, which I'm honestly probably not going to give you, has 3 terms, but it's like x to the 4th plus 7x squared plus 10. Okay. That is factoring like normal, except you're dealing with an x squared term, right? So this would be x squared plus 5, x squared plus 2. I'm not super worried about that right now, though. Honestly, I would rather be able to factor by grouping. But that is the other thing that showed up on your other test. Okay, but let's work with what we have. Okay, so when we're factoring by grouping, we're grouping 2 terms together. Usually you're going to group the first 2 terms together, and usually you're going to group the last 2 terms together. Okay, so if I just rewrite this. Okay, I'm going to group these first 2 terms together and these last 2 terms together. And I'm going to try and take the greatest common factor that they have out and see if we can get a common factor between those 2 other terms. Okay, so in the first 2, you should notice that, and this should be cubed, and this should be squared. Okay, the greatest common factor between these 2 things on the first, like on the left, is x squared. So if we factor out the x squared, we get x plus 3. On the right, both of these things share a negative. So if we factor out that -1, then we have x plus 3. And again, that's still equal to 0. And then we ask ourselves the same question. Okay, we see what's in common, and now we just have 2 terms though, right? We have this term, this x squared times x plus 3, and then this right term, this -1 times x plus 3. Chances are it is going to be grouping. The quadratic stuff, if you're able to do the questions above it, you can really do the x to the 4th type stuff. It'll most likely be factoring by grouping. Okay, but back to this part, right? So we group. We've already done the grouping. But now we have 2 terms. We have x squared times x plus 3 and -1 times x plus 3. X plus 3 shows up in both of those. So if we factor that out, we are left, like literally if you just cover up the x plus 3's in both, you're left with x squared minus 1. All right, and then we have stuff that we can solve. So either x plus 3 is equal to 0, or x squared minus 1 is equal to 0. Okay, and if we do this, x equals -3, and x squared is equal to 1, so x is equal to plus or minus 1. Keep in mind the square root of 1 is just 1. Okay, because what you would do, you have x is equal to the square root, like plus or minus the square root of 1. Square root of 1 is just square root of 1, so x is equal to plus or minus 1. You could also factor it. Right, this is the difference of squares, so you could factor as x plus 1 times x minus 1 is equal to 0 and go from there. These are just different ways to do the same thing. Okay, but you could ask what are factors of -1 that add to 0? And that'd be how you do it. All of them are fine. Just do the one you're comfortable with. Okay, so now we have 3 zeros, and we plot those on our graph. So we plot -1, +1, and then -3. Okay, so we plot those points, and then from our original, from our start, right, we got the general shape of the graph, so we know what the shapes going outward, right, going to the right and going to the left look like. So we know our graph is going to come up, and we know it's going to go down to the left. Okay, how did the x on x plus 3 get a squared? Got it. Okay, so you are talking about this guy. So if you look above it, right, we group these two terms together. Okay, the greatest common factor between those two terms is x squared. We can pull an x squared out of x cubed, and we can pull an x squared out of 3x squared. So when we do that, right, we factor out the x squared, and we're left with x plus 3. Okay. Again, I can go back to that, but I want to keep going. So we did the leading coefficient test, we did the finding zeros, and now we need to use the intermediate value theorem to test and see what happens in between those zeros. Okay, so all we're doing is we're plugging in numbers between the two sets of zeros. Okay, so we need to test in between -1 and 1, and we need to test in between -3 and -1. So let's test between -1 and 1. That just seems like an easy thing. Okay, so let's test 0. Okay, so if we plug in 0 into our original, whoops, no, I don't want that. Right, all the zeros just cancel out the variables, so we're left with some negative number, specifically -3. It doesn't matter what the magnitude is. Okay, but we get a negative at 0, so we get something below the x-axis at 0. So because we get it at 0, we also get it in between the two red points that we already plotted. Okay, so we get a graph that looks like that in between -1 and 1. Then we test in between -3 and -1. So let's test, say, -2. When we do this, this is -8 plus 12 plus 2 minus 3. That's going to give us a positive number. Okay, so that means all of these numbers are going to be positive. Okay, so our graph is that. I'm expecting work in green, I'm expecting work in red, and I'm expecting work in blue. Your overall answer is the graph, okay? I'm also confused how -1 x plus 3 equals 0 changed to x squared minus 1. Okay, so when we factored, right, my guess is that you know how we factored out a -1 from this stuff. Okay, so we pulled out the -1, and we end up with x plus 3. Right, if we just factor out negative from a negative, we get a positive. So negative from -x, we get positive x. Negative from -3, we get positive 3. So then we get really two different terms. We get x squared times x plus 3 from the like color. And then from negative x minus 3, we get negative 1 times x plus 3. Okay. So those are two terms, right? We have a blue term and we have a yellow term. The thing that shows up in both of those terms is x plus 3. Right? So if we pull out that x plus 3, literally all you're doing is you're covering up the x plus 3's. Also, this might be confusing someone. That should be a plus. But if you're pulling out x plus 3 from both of those things, the only terms you're left with are x squared minus 1. Right? Because x plus 3 shows up in both the blue and the yellow part. So if we pull that out, we're left with x squared minus 1. Right? X plus 3 is just like a greatest common factor between those two terms. Does it matter how far up and down it goes for the intermediate value theorem? No, it does not. I don't care. Just so long as you know that one negative value implies a whole bunch of negative values, or one positive value implies a whole bunch of positive values. Okay, so that's one of the longer ones, right? I think this was, let's see if this is 2. I have to do a little bit of math. If this is 2, I think this factoring part is probably 3 points. And then I think this was, no, I think that's 2. So 2, 4. I think this graph is worth 3 points. Okay, so if this total is like a 7, maybe 8 point problem. But you have to be able to show your work, and then you have to show that work in a graph as well. Okay, so that's number 9. I'm hoping we've seen that for long enough. Let's go on to number 10. And so I'm going to do this problem, and then I can fill in any gaps along the way. Number 10 is one of those problems where different types of these problems could come up. So we have to be able to do all of them. Okay. I'm going to do this one, and then I'll explain the other types that you could find. All right. So the first thing when you do these problems is we're going to find the vertical asymptote. Okay. Vertical is the easiest. It's the most straightforward, and it really should be the easiest to find. Okay. So for vertical, all we do is we take the denominator and we set it equal to 0. I saw a lot of people try and take the numerator and set it equal to 0. That is wrong. Okay. But then we solve, right? So negative 3x squared is equal to negative 12. X squared is equal to positive 4. So x is equal to plus or minus 2. So we have two verticals. Positive 2 and negative 2. And then we label it. Then we worry about the horizontal. Okay, vertical is always the most straightforward, right? You just take the thing in the bottom of the fraction, you set it equal to 0, and you solve. That concept should make sense. Okay, because those are when things can't exist. Again, we've gone over that in class. You don't need to necessarily understand that for this. But 1 over 0 doesn't work, so if you set the denominator equal to 0, those are your asymptotes. Okay, horizontal is a little bit trickier because there's different conditions, right? But overall, horizontal, I'm going to do green. Horizontal has to do with comparing the degrees of the numerator and denominator. Okay, so the degree of this numerator, right, there are no variables, so the degree of the numerator is 0. For the denominator, the highest degree in the denominator is 2. So m, we'll call that m is equal to 2. In this case, n is less than m, So that tells us that y is equal to 0. Okay, that's one of the conditions. We're going to go through this this problem first, and then I'll talk about the other two. Okay. You just got to know that if the numerator degree is ever less than the denominator degree, your horizontal asymptote is 0. Okay. Once you have the vertical and horizontal or slant, okay, you have kind of the outline of the graph, which is conveniently red and green because this is such a cheerful time of year. So then we test, and we test to the left, we test to the right, and we test in between. So we test somewhere in between. So let's test 0. So that's going to be 1 divided by -3 times 0 squared plus 12. This is going to be 1/12. And then you ask yourself, is 1/12 above or below 0? Right? 1/12 is positive, so it's above 0. So that means that everything in between our two asymptotes is going to be above that horizontal asymptote. Okay. Now, things I notice on the test, both the retakes and the normal test, I'm not expecting complete accuracy, but like, don't cross your asymptotes because then you're wrong. All right. And try and draw them pretty close. Like this should be your most accurate drawing. Use a straight edge. And I'm not like you don't have to have super accurate points, but you need to have things in between the two vertical asymptotes and above the horizontal, and that should be pretty explicit, right? So be careful with that. Don't draw stuff that looks, like this when you're drawing to the right. That doesn't work because it's not right. Okay, just be to the right or in between or whatever. Okay, so we tested in between. Test to the left. So let's test, let's say -3. When we do this, we get 1 divided by -27 plus 12. Doesn't matter the magnitude. This is going to be 1 over some negative number. So -15, I think. -1 over 15 is below 0, right? So it means our graph is going to be below, and it's going to be hugging those asymptotes. And then we test to the right. Luckily, because we have a square, it's going to be the same thing, right? So -3 times 3 squared plus 12. You can do this math, but this is going to be equal to -1 over -1/15. Okay. And that's also below 0, which gives us this part of the graph. So that's how to do this one. Okay. Vertical, horizontal, test. All color coded. Things I don't want to see. Stuff that looks like this. This is in pink, so you can't really see it. Nope. Let's do it. Well, whatever, this will work. Right? I saw a lot of people do this nonsense. Okay, that's not right. That's not hugging both the asymptotes, or all of them. It's got to come down and almost hit the horizontal, but not quite. This is what I'm looking for. Okay. Now, that is one condition. All the other conditions only have to do with the horizontal, right? So in this case, we had n is less than m, right? So for horizontal, three conditions. The degree of the numerator can be, hi Ryan, the numerator degree can be less than m, in which case y is equal to 0. The numerator degree can be equal to m, in which case you take the ratio of the leading coefficients. Or the numerator degree can be greater than that denominator degree, in which case there is no horizontal. And if this is the case, you have to check for a slant. I'll be honest, this condition probably is not going to happen on your exam. Just for the sake of time, I want to give you something that is a little bit more manageable. So just keep that in mind. But if the numerator degree is greater than that, there is no horizontal and there is a slant. We're probably not going to have that condition though. We will definitely have one of these two. This bottom one, so when the degree of the numerator is equal to the degree of the denominator, right? So let's say we have something that looks like, right? So our function f of x is equal to like 3x squared over 5x squared minus 7x plus 1, okay? The degrees are equal, so that tells us to take in order to get the horizontal asymptote, that tells us that our horizontal asymptote is the ratio of the leading coefficients, right? So in this case, that would be 3 divided by 5. And then that's it, right? That's just the horizontal line at 3/5. So if 1 is like right there, 3/5 is like right here. How many will you have of this? Just one. It's not going to be like the last test where I'm expecting you to know every single thing. I do want you to know every single thing, but I want you to show me that you know how to do one. Okay, so there's just going to be one. There's going to be one of this problem too, right? So all these major problems, just one. Okay, so that's what I'm expecting for number 10. Number 11. Okay, number 11, all we're doing is simplifying and rationalizing. That's what those should say. And in order to simplify and rationalize this, you're going to have a difference or sum of imaginary numbers in the denominator, which is what we have. In order to make this right, we have to multiply by what's called the conjugate. Okay, so the conjugate of, let's say, a plus b is just a minus b. All you're doing is you're changing the sign in between. So what we need to do is we need to multiply by the conjugate of the denominator over itself, which we can do because we're really just multiplying by 1 in that case. Okay, so again, conjugate, all we're doing is we're changing the sign in between. And then we distribute and FOIL and all that stuff, right? So 9 times negative 8, it's negative 72. 9 times 7, that's 63. So we get negative 72 plus 63i in the numerator. In the denominator, we FOIL, right? So negative 8 times negative 8. That's positive 64. Negative 8 times 7i, that's negative 56i. Negative 7i times negative 8, that's positive 56i. And then negative 7i times times positive 7i, that is minus 49i squared. Okay, that in and of it, well, okay, let me backtrack. Knowing what to multiply by, that's 1 point. Being able to FOIL all of this stuff, that's worth another point. And then the simplification is worth another. Now the simplification gets a little bit harder because you have to deal with this I squared. Okay, but let's take a step back from that real quick. First thing, numerator. Numerator is as simple as it can get. Okay, there's nothing we can combine. In the denominator, negative 56i plus 56i, that's just 0. And we have 64 minus 49i squared. Do we have to show the plus or minus 56i, or can we just cancel out immediately? If you know how to take the difference of squares, just go for it. That's fine. Okay. So the next part is dealing with the I squared. I squared is always equal to -1, right? I is the square root of -1, so if you square that, you get -1. So then we have 72 plus 63i over 64 minus 49 times -1. And you don't have to show this step. I just am so people can see what's happening. So then we have 72 plus 63i over 64 plus 49, which is 113. Then this would be your answer. That takes a lot longer to explain than it does to do. So I promise that shouldn't take very long, so long as we know how to FOIL, and we know what I squared is. All right. Solve each system by elimination and then Cramer's rule. I'm going to try and do this pretty quickly because we just covered this. So I'm hoping that we remember. For number 12, we have like 3 major steps. The first is to reduce the system of 3 to a system of 2. Then, sorry, there you go. Then we solve the system of 2. And then we solve for the third. That's the general idea of what we're going to do. Okay. In number one is really the hardest part. Okay. We have to choose one variable that we're going to eliminate from 2 different equations. Okay, so as I look at this, I'm going to deal with S. So I'm going to choose to eliminate S, no matter what we're doing. Okay, so I'm going to take these first 2 equations and add them together. Right, so 4r plus -6r, that's -2r. 2s plus a -2s, that's 0. And then -3t plus 4t, that's just plus t. And then -15 plus -20, which is equal to -5. Okay, and while we're looking at, I think while Caleb's looking at number 11, I'm going to still talk about number 12 so we can not be here for like 3 hours. So we took a system, we took 2 equations in our system of 3 and we eliminated S. All right. Then we just take another 2 equations and do the exact same thing. Okay, so what I'm going to do then now is I'm going to take also as a caveat, you can always like pause this and rewind like during the live, that's fine. So I'm going to scroll back up just a little bit. I'm going to take these 2 equations and eliminate S, which takes a little bit more doing, right? So I'm going to multiply the top. So I'll just rewrite this. So -6r minus 2s plus 4t is equal to -20. -2r plus 3s plus minus 2t. Is equal to -2. We're trying to eliminate S, so I'm going to multiply this top one by 3 and this bottom one by 2. When we do that, we get -18r minus 6s plus 12t is equal to -60. -4r on the bottom plus 6s minus 4t is equal to -4. Add those together, get -22r plus 8t is equal to negative 64. Okay, so in doing that, we reduced the system of 3 into a system of 2. So that's step 1, okay? Step 2 is to solve this system. So we take negative 2r plus t equals negative 5. And negative 22r plus 8t equals negative 64. You can choose any variable to eliminate or not do this way at all. I'm going to eliminate t. So I'm going to multiply, actually, yeah, I'll get rid of t. So I'm going to multiply the top by negative 8. And when we do that, we get 16r minus 8t is equal to negative, or positive 40 in this case. Right, we multiplied the top by negative 8. And on the bottom, we're just going to keep that the same. Add those together, we get negative 6r is equal to negative 24. So r is equal to 4. We plug this r equals 4 into one of the other system of 2. Right, so let's do negative 2r, whoops, negative 2r, which is 4, plus t is equal to 5. Then we just solve, right? So negative 8 plus t is equal to 5. T is equal to, what, 13? And then once we find r and t, right, we solved the system of 2, so we did step 2. And then we just plug both of those into one of our original 3 and solve for s. Right, so if we do that, I'll just take the top one, 4 times r, which is 4 times 4, plus 2s minus 3 times 13 is equal to 15. It's a negative 5. That's fine. We're process, right? And in fact, like, we did the first step right. We reduced to a system of 2. We got the first variable right. So we'll stop there, right? So we plug r and t back into one of our originals, and we have to solve for s. Once we solve for s, we do the problem. Okay. Oh, I get it. That should be negative 5. Is that right? Yeah. Okay. So then negative 8 plus negative 5, or 8 plus negative 5, that should be positive 3. Got it. Hello, Kevin. Good luck on your final. And I'm sorry. Right, so we get r, t, and s, and then we're done. Okay, 13, Cramer's rule. First thing we do is we get a coefficient matrix. That's negative 3, negative 2, 2, negative 3, 6, negative 5. Whoops, not negative 5. There should be a 0 there. And then 1, 2, and negative 5. So we get our coefficient matrix, and then we take the determinant of that. Oops, not equals. We want the determinant of this thing. In order to do that, we rewrite the first 2 columns. It seemed like everyone knows how to do this pretty well. So I'm going to go through this quick. We take the diagonals. We multiply diagonally and then add to the right. So negative 3 times 6 times negative 5 plus -3 times 2 times 2 plus 1 times -2 plus 0, or times 0. Yes, you are right. These should be switched. Okay, so that means this should be 2. And there should be a 0 here. All right, so we do it 15 times 6. And 15 is 30, 60. And 2 more, right? 36, 90. Okay. So this is positive 90. This is 0. This is -4. Okay, so this is going to equal to 86. That's the top. Then we do the other diagonals. So 0 times 6 times 1. 2 times 2 times -3. And then -5, -2, -3. That's 0, 4, so -12, 15, so -30. So that's -42. And we are subtracting these two things together. So -86 plus 42, sorry, 86 plus 42, that's 128. And that's our determinant. That's the first step. And that's, I think that was worth 3 points on the rubric. Okay. And then we set up x, y, and z, which should be the easy part. So x, that's going to be the determinant of our coefficient matrix, except we are changing the x column to the answers. Everything else is the same. All right, so that's these guys. And then we're going to take that all over the determinant, which is 128. Same thing for y. Y is going to be the determinant of our coefficient matrix, since we're changing the y column. And then the same for z. And then that's full points. Okay. Again, 3 points. I think I set this up 3 points for this part. And then 1 for each of these. That's 6. And then I think I had like 2 for actually doing the coefficient matrix. And then 1 just is, I don't know where the other one was. But I think total on the quiz was 9. On the test was 9. We can use our calculator to find the other determinant once we find, yes. Yeah. So for juniors, you actually need to solve for this. You can use your calculator for those and then get an answer. For seniors, I'm just expecting this work that you see on your screen. How many total points is the final exam worth? Hi, Max. It's 15%. So not a whole lot. I'm going to be generous as much as I can be. So you'll be fine. Don't worry. I'll take care of you. So that's number 13. So this is the last part for the seniors. Okay, and then we'll move on to the junior stuff. State the parent function. It's shift left and right. That should be left. And up and down, and any reflections. Okay, so there are 6 parent functions. We need to know all of them. How many points for solving? This stuff up here. This stuff up here for seniors, this is what I'm looking for. If you solve, that's great. It's not going to do anything else. I'm expecting you to be able to set it up. For juniors, I'm expecting answers. So I think for seniors, I think the total is like 7 points, and then for juniors, I think it's like 10. So 1 for each correct answer. Don't worry about that though. That just takes more time from other stuff. So again, number 1, parent function. Again, I'll explain this question first, and then I'll explain the rest. All right. This parent function is 1 over x. The parent function looks like this. Okay, that's the rational function. It's the asymptote question that we start with. That's not great, but that's what it looks like. Am I saying the juniors are smarter than you? I didn't know. That's not at all what I said. You can think that. They're just at a different place. Anyway, so if this is our parent function, that's 1 over x, right? We need to be able to see that that's the parent function. This parent function is shifted left 1 unit from the center, right? I know it's hard to see on the screen, but hopefully you can see it on your PDF. But it goes left 1 unit, right? So our parent function is 1 over x. It is left 1 unit. And you should also notice it's shifted upside down. It's reflected upside down. I didn't imply anything. I don't know what you guys are talking about. So reflected upside down. Okay. This is worth points, just being able to determine the parent function, the shift left and right, up or down, and then its reflection. Okay. The other set of points, so if this is worth like 2 points, the other part is worth 3 points. I think I got to go back to the rubric. It's the same way I graded the other one. But left 1 means we are changing the input by 1. So we do x minus 1. And then upside down, we're just plugging in the negative. Right? So this negative means upside down. And then this minus 1 says move left 1. That should be plus. Plus 1. Plus 1 means left 1. That's all I'm expecting. This isn't, I'm not going to put like the stretches and shrinks. That just makes things too complicated. It'll be simple, right? So just as a recap for this stuff, different parent functions we got to know. Okay, so 1 over x is one of them. That's this graph. And while you're looking at these, you should notice that they're all centered at 0, 0. Right, so 0, 0 is like the center of all these graphs. Okay, so this is 1 over x. And I realize, yeah, I'll do it this way. Okay, another one is just the linear function. So that's y equals x. Okay, the other is the quadratic. We should all know what that looks like. It's the parabola. Then we have the square root. So that's the square root of x. Then we have the cubic. Again, only one of these are going to show up. And I would anticipate one that we've done quite a bit. Okay, so cubic. Can we get this type of one on the final Um, I mean, the difficulty of it will be the same. It won't be the same parent function though. I can guarantee you that. Okay. And then the last parent function, which you saw on the packet, I know a lot of, um, is the absolute value. It's the absolute value. It's just that corner function. Okay. Um, so we just have to put the equation for the answer. No, no, no. Like almost, but I'm looking for you to identify the parent function. So that's this. Identify left or right, up and so left or right, and up or down, and then a reflection upside down or not. Okay. That's what I'm expecting up front. And then I'm expecting the equation. So I want you to identify all those things. That first part should help you get the equation if you do it right. Okay. Just as a recap, so we have those parent functions. I'm going to scroll up a little bit. If we change the input, right? So if we change something like within the actual function, right? This means write h units. If we go and change the output, right? So something on the outside, that's up k units. If we put a negative out front, this means upside down. And if we put a negative inside, that's like switch directions. For most of these look the same, but we're just switching directions. So we're going from left to right. Okay, there's a bunch of examples of those on that packet that I gave you. There's a lot of absolute value, so I would anticipate an absolute value question on the test. Okay, and just being able to do this stuff, right? So, hint, right? Look at the parent function's absolute value of x. Okay, all of that is the senior stuff. Okay, so I'm gonna kind of take a second, and then we can get to the junior stuff. Look through this, make sure things make sense, and if you don't have any questions, seniors, you are pretty much free to go. And then juniors will work on the log stuff here in a second. Okay, so I'm going to mute myself. I'm going to go get some water, and then I'll be right back. So 2 minutes, 2-minute break. If you need to scroll through these, just scroll through the window thing. You'll be fine. I'll be right back. Good. I'm glad it helped. For seniors who are still here, I'm going to break this up as soon as it's actually like uploaded, like legitimately uploaded, like not like you're just on the same page the entire time. As soon as that happens, I'm going to try and split it up so you know what time is what question, so you can just go directly to it. Bye, Ethan. So that'll help out. Okay, seniors or juniors, you don't have the luxury. You're tomorrow. Will that log x be one of the parents? No. Don't worry about log x, because log x looks a lot like x squared. In fact, it's kind of the same, but not really. So don't worry about that. Okay, So we'll get through this log stuff. I'm gonna be really forward with you. I don't anticipate giving you this many questions because it just seems like overkill trying to do this and explain it all, right? So I'll probably take one or two off. So the first couple have to do with the one-to-one property, all right, in both logs and exponential. So I'm going to change songs so I don't go insane. Okay, so one-to-one property, all right. So number 1 and 2 and 3 and 4 and 5. Well, 4, up to 4. All right. These are the change of base. So this is the stuff that we first started off on. Okay, and this is the exponential stuff. So what we need to ask ourselves for number 1 and 2 is what are common bases between the left and right hand side. Okay. 6 should be your answer, right? It's usually the lowest term. Sometimes it's not, but a good guess is the lowest term that you see. Okay, so 6 is going to be our answer, right? So we're going to leave the left-hand side alone, and we're going to try to find 6 to some power is 216. You can plug this into your calculator. You can do it by hand. It's 6 cubed, right? 6 cubed is 216, which isn't immediately obvious, but you can search for that. That's not that hard. And once you get this, once you get a common base on both sides, like number 1, right? So this is a simpler problem. Once those common bases are there, they kind of cancel each other out. So then we can use the one-to-one property. Yes. And kind of just cancel those 6's. So then we have 2x minus 2 is equal to 3. And we just solve for x. And fractions are okay. Number 2 is a harder version of this problem, right? Because there's 3 terms now, and they're bigger, okay? But it's still the same idea, okay? We look for a common base between all 3 of these terms. We look at the small one, and it's usually that, okay? So let's try 5, right? 1 over 125 is 125 is 5 cubed. So 1 over 125 is 5 to the negative 3. Okay, so that's the first term. The second term, 625, I'm going to delete these, is 625 is 5 to the 4th, right? 5 cubed is 125 times 5 is 625. So 625 is 5 to the 4th, and that's being taken to the power of negative 3b plus 2. Right, so that is that number, and then the exponent stays there. That's all equal to 5 squared. In order to use the one-to-one property, though, we have to have everything on one base on the left-hand side and everything on one base to the right-hand side. Okay? So we have to combine these two things. Okay? And we just use the, well, first we gotta simplify a little bit, my bad. So 5 to the negative 3, and then we have a power of a power. So we multiply. So we have 5 to the negative 12b plus 8. Okay. Then we're multiplying things with the same base, so we're adding their exponents. So then we have 5 to the negative 12b plus 5 is equal to 5 squared. And now once we get it down to this, okay, once we get the same base on both sides, just like on the problem to the left on 1, we can just kind of cancel those out. And then we just have an algebra problem. And then I'm trusting you to solve that. I think we're past that point. I think Number 3 we're going to skip. That's a bad problem. I'm sure we can do it, but I couldn't figure it out immediately when I was helping someone, and then I just said it wasn't going to be on there, so just plan on number 3 not counting. Okay. Yeah, so don't worry about number 3. Yeah. I think you could do that on a calculator. I'm not expecting that yet, though. So let's move to number 4. Number 4 is exactly like number 1, except it's easier. Okay, we can use the 1-to-1 property here because we have log base 14 of something is equal to log base 4 of something. There's nothing outside, that we're not adding anything, we're not multiplying by anything. Everything is inside both of the logs. I just spent a long time solving that one. Good. It's good practice. It's not going to be on there. So once we have everything in one log on the left and right, we can just kind of cancel out those logs. Now I'm curious. I mean, you could get an exact answer. Except my hope would be that some stuff canceled. That was the idea behind those first couple of problems, which is why number 3 just kind of stood out as like, why is this here? All right, so you should get this. That's some decimal. I don't know what that decimal is, though, because there's no common base between 18 and 46, unless I'm missing something. Because it's not divisible by 3 or 9. It's divisible by 2, but that doesn't really make any difference because we don't know what to do with the base after that. Anyway, solve number 4, add 5 over. Subtract 6. B is negative 14 over 3. Again, fractions are fine. And then every question after this just kind of adds layers. So there's some condensing, there's some expanding, but everything's kind of the same idea, so long as we know those properties that were in those videos that I made earlier. So then negative 0.165577, whatever. It's not totally exact, which is why these answers are better. Which is why I'm not expecting to be able to get it just yet. So you're probably right. You probably did it on a calculator correctly. But it's not exact. Yep, getting there. Okay. Number 5. Okay. We have a log of negative 9p. And we need to get that by itself first. In order to get that by itself first, we have to divide out that negative 7. So you're still using like these algebraic principles, right? Get things by itself by dividing out, multiplying, adding, whatever. Right? So you get log base 3 of negative 9p. So we just divided out the negative 7s. Once you have that, though, you got to think a little bit, because this is where it starts to get new, right? And what we have to remember for this is that if we have an exponential, right, this is the same thing as a to the power of y is equal to x. Okay, and these things, they say the same thing, but the idea that you have to get in your head is that logarithmic is the inverse of exponential. So logarithmic undoes exponential, exponential undoes logarithmic. So we have to undo this log base 3. In order to undo a log, you have to take that log to that base's power. Okay, so let me write this out. Let's just say that this is equal to c. Okay, in order to undo this and solve for b in this case, right, we have to undo that log base a. So we would take a, and then everything is going to be to the power of that. And what we do to one side, we have to do to the other side. So we're going to do that. So we take 3, we take that base as a base of everything. And we get that. What this does is it cancels out the 3 and the log 3. So we're left with negative 9p is equal to 3. So p is equal to negative 1/3. Number 6, again, we have to get everything on the left-hand side in one log. Okay, so this brings up another property, which is the quotient property. And the quotient property says that if you have the difference of 2 logs with the same base, you have their quotient inside. So we're using this here, right? So we have logs with the same base, and we have a difference of them. So we're going to use that quotient property to combine them. And that's still equal to 2, right? We didn't change anything. All right. Then we have to use that property that we just used before, right? So we take everything as a base of 4. And what we do on the left, we have to do on the right. This cancels out the 4 to the power of log 4. And we're left with negative 3x minus 4 over 3 is equal to 16, right? 4 squared. And again, I'm hoping at this point you guys can kind of take over. So you would still solve for x. I'm just not going to do that right this second. Okay. Number 7, you have the same idea, right? If you have the sum of 2 logs with the same base, that's equal to the product inside. Oops, not a. Okay, so you're just using that, right? So if we want to get everything together, which we have to do, except this case, we just use the one-to-one property, right? Because we have the log base 5 on both sides. And then we solve from there. You don't have to get that far. I'm just bored. Okay, last 3 problems. Number 8 and number 9 tell you to move the reverse direction of what we just did. So instead of condensing in order to solve, we need to expand. Okay? So in other words, we moved from left to right on these last couple of problems. in these next couple, we have to move from right to left. Okay, so that's the direction we're going to go, right? So we have to move from log base a of b over c into the difference. And we have to use log base a of b over c, and we have to move to the sum. Okay, so we have the product of two things, right? We have c to the fourth times square root of a. So we're going to do log base 7 of c to the fourth plus log base 7 of square root of a. And then same, well, we'll get to that here in a second. Okay, now this takes care of the product property. That last property that we went over, that last property is the exponential property. Okay, and this says that if you ever have log base a of x to the power of b, right, we can rewrite this. We can just take that exponent inside and move it out front. Which makes calculation a little bit easier. Okay, so for that left-hand term, we take that 4, put it out front, and that's 4 times log base 7 of c. The log base 7 is square root of a, right? The square root of a is equal to the a to the 1/2. So we can rewrite this as 1/2 log base 7 of a. Okay, number 9 is just a different version of this, right? We have an exponent out front overall, so we do that first, right? So we have 2 log 2 of 7 over 5 to the 5th. Then we have a quotient inside, so we do 2 log base 2 of 7 minus log base 2 of 5 to the 5th. And then we see an exponent inside, and we put that up front. And then that's our answer. All right, last question, and this is really the easiest on this part. Okay, we just have to rewrite log base 19 of 361 is equal to 2. Okay, and you should know log base a of b, let's say that's equal to some value c. This is the same thing as a to the power of c is equal to b. Okay, so on this, we have 19 to the power of 2 is equal to 361. And that's all I'm expecting. Okay, that's that part of the exam. So I want to make sure people don't have questions on that, because again, I understand this is new. I'm going to go a little bit easier probably than I gave you on the practice test. But what questions do you have? Okay, 2 questions. Is there no finding the log stuff with no calculator part? Is there stuff with finding a calculator? No. No. I'm not a huge fan of that stuff anyway because it's not exact. I will teach you how to do that. We just ran out of time in the semester. Can you give us bonus questions on the final? No. No such thing as extra credit. Potential help, but not extra. Okay. I'm hoping there's no other questions. If you guys do have questions over this part, especially this part 3, keep in mind those videos that I assigned you for homework a while ago. Those are still up, and they explain all of this stuff, and there's more examples. There's also that bank of questions with, I think, other examples. I don't think I just deleted stuff. Um, that's there for you too. Like I've said earlier, I'm probably going to go easier than what you're seeing on this. What about those evaluating log questions I don't know if there's no solution? Um, Again, that's a question for another day. Is the Excel sheet still due on Monday? Yeah, I need to actually put that in, and also email all of your parents. Um, no, even if I did put those questions on, Drew, um, I wouldn't expect you to know that there's no solution yet. I would expect you to be able to do the math correctly, which if you get an answer, chances are you did. But those won't be on there anyway, so it doesn't matter. Following up on Stu Whitaker's question, gotta work on spelling. Following up on Drew Whitaker's question, will the end up no sleep? No, it won't. I don't know what you were trying to say, but I think I understand. It won't be. There won't be no solution questions on the exam. And again, even if there was, I would still be grading you on the work that you did in order to get to that. But I probably wouldn't grade the quote unquote no solution part. I'd probably just grade your answer. I hope that Lakers. Yeah, that's where the log x is negative. Again, I never actually taught that yet. We kind of went over it in classwork a couple of times, but there's normally no reason to have a negative in there anyway. So even if it were to show up in like legit life, um, it wouldn't it wouldn't make sense. It'd be like it'd almost be like going back in time. Like usually you're using logarithms as a like a forecast in anything. Okay, so having a negative in there wouldn't, like, you can't forecast the past. You just kind of tell it. So it shouldn't make sense in any way we do it. All right. I get the Lakers are going and Schoen's geeking. What questions do you have so I can answer them before tomorrow? Okay. I'm assuming that there's no questions. I'm gonna call it. So I'll give you until 9:17 or so. Is this video gonna be posted before tomorrow morning? It's tricky. I can't actually say yes or no to that. So what I would do is to just leave this window open. Um, I know you guys have a problem with leaving windows open. Just scroll to the beginning and leave it there. That's the best way that you can guarantee that you're able to watch other stuff. Okay. Um, it will be up. It just sometimes it takes time on YouTube's part. I don't know why. It shouldn't take. I mean, I get like the uploading part, but it shouldn't take like 12 hours. So at some point in the next 8 hours and 44 minutes. It should be up, but I can't guarantee it. Thank you, Jack. I appreciate your appreciation. Okay, so T minus 1 minute for other questions. We can also, I'll be here, I'll be at school probably by 8. I'll probably be there earlier. But like, if you have questions and you want to come in early, by all means, come in. I'm glad you're watching basketball and this. Okay. It's 9:17, so it doesn't seem like there's any other questions. So I'm going to shut this down. Um, Stream the game. No, but probably gonna go play Counter Strike. Again, if you have questions, let me know tomorrow morning. I'll be happy to answer. Don't get there like 2 minutes before and expect answers. Get there like 20 minutes before, and I'll help you out. All right. Um, yeah. So good luck tomorrow, and I'll see you then.